All right, Mr. Ahmed here for section 2.6. Quick warning, this video I realize might get a little bit long. I will do my best to keep it as short as possible, but just a heads up, it's kind of a longer lesson, so make sure you have the time to sit through the whole thing. All right, so goal for today, essential question, how do I solve an absolute value inequality? So when I take a look at this here, first example, it just says the absolute value of x has to be less than or equal to 2. So what are some possibilities that work for this? I mean, I can think of one thing. I think 1 would work. 1 could be less than 2. Another option could be 0. 2 is equal to 2. Now, are there some other things that would work? Now, 3. 3 would be too big because 3 is not less than 2. Now, in the absolute value realm of things, I also have to think of some negative numbers that would work. So if I put in -1, the absolute value of -1 is 1, so that would work. I also think -2 would work because the absolute value of -2 is also 2, that is, or equal to. Now, some things that don't work, again, would be like 3, 4, 5. And then we'd also have things like -5, -6. Those absolute values will be too big. So if I were to graph this on the number line, my solutions, I know that it works at -2. Here's 0, -1, -2. That's a possibility because it was or equal to. I also went all the way up to +2. And all of these values in between worked. So when I think back to my compound inequalities, which graph was shaded in between? That was an and. Okay, so as we progress through this lesson, we'll see that our absolute values are going to also lead us to some compound inequalities. All right, so steps to solve. First step, again, is going to be to isolate the absolute value, just like when we were solving an absolute value equation. After that, we're going to set up the compound inequality. We have to choose and or. So that's what we're going to go over here. All right, then we're going to solve for x for both of the inequalities, and then we are going to graph our solutions on a number line. So the first one we're going to talk about is less than or equal to. With a absolute value being isolated, if the absolute value is less than something, we are going to set up an and inequality, okay? And this value of y also has to be greater than 0. Okay, I can't have negative numbers be possible in this scenario. So when I set up this inequality, I'm going to have to write an and. You can do it a couple of ways. You could write it as the compound inequality, or you could use the word and. I typically think it's easier to use the word and. When I set up the first one, I'm going to have to say that whatever's inside the absolute value, in this case it is x is less than y, and x is also going to be greater than, we have to flip the sign, negative y. So this value is going to become negative when we write the second half. So, I mean, the y piece makes that a little bit tricky when I set up the first example. So when we hop in with some numbers, it's going to be a little bit more obvious what we're doing here. So first one, absolute value is isolated, and it is a less than. Less than, we think and, LA. So I'm going to set up an and. So I take what's inside the absolute value. In this case, inside the absolute value is just x, so I would write the first one just as it's written. X is less than 3, and x is greater than, flip the sign, make it negative, -3, okay? These ones are both solved. X is isolated, so I'm going to put 0 up. I have to get to -3, -1, -2, -3, and it is not or equal to, so it's an open circle. We're also at +3. And when we think of the ands, keep in mind we typically shade it in between. When I look at this, it says x is greater than -3, greater than to the right. X is less than 3, less than to the left. So again, I will shade in between. So all of my solutions are the numbers in between -3 and 3. So I kind of didn't do a very good job of having this on the screen. I'm going to explain that one more time. That's my bad. I put up our -3 and 3 open circles, and x is less than +3, so less than to the left. X is greater than -3, greater than to the right. The ands we shade in between. next example. This one's just a little bit trickier because the absolute value is not yet isolated. So our first step is to isolate the absolute value. In this case, we have 3 times the absolute value. To undo multiplication, I will divide by 3 on both sides. And we get absolute value 2x plus 9 is less than or equal to, keep my bars nice and big so I don't think that's a 12. 39 divided by 3 is 13. Okay. Now, the absolute value is isolated, so I'm going to rewrite both inequalities. I'm going to do that up over here nice and neatly. 2x plus 9 is less than or equal to 13. The first one stays the same. Second one, 2x plus 9 and is in between, is greater than or equal to, flip the sign, make it negative. So we have a negative 13. So the first one's rewritten exactly the same. Absolute value's gone. Second one, flip the sign, make it negative. Okay, that's kind of my shortened way of remembering it. Now we got to solve both, so I'm going to subtract 9 from both sides. 13 minus 9 is 4. So I have 2x less than or equal to 4. Divide 2, and x is less than or equal to 2. So that's our first one. I'm going to solve the second one before I start graphing, just so I have an idea of what my graph's going to look like. So subtract 9 again, subtract 9. Negative 13 minus 9 is negative 22. So 2x is greater than or equal to negative 22. Divide 2, x is greater than or equal to negative 11. So these circled are my 2 absolute values, and in between is an and. So we should be shading in between. So on my number line, I have to get from negative 11 to 2, so we're going to make this one pretty generic. 0, negative 11, 2. All right, I didn't count all the way over to negative 11. You don't have to draw these to scale. Our circles are both closed, and we are shading in between. Let's see if it makes sense. X less than to the left. X greater than to the right. So again, it matches. We are shading in between. The solutions are all the numbers in between negative 11 and 2. So that takes care of our and statements. The next possibility is if the absolute value is greater than. If the absolute's greater than, we are going to use an or compound inequality. Our process to rewrite is going to be the same. Take what's inside the absolute value, x in this case. First one, greater than y. Okay. And then for the second half, take what's inside the absolute value, flip the sign, and make it negative or in between. So keep in mind our ors typically shade opposite directions. Greater than, you could think go, or. Greater, go, or. All right, so process, still have to isolate the absolute value first. So in this problem, we have to move the negative 1. To move the negative 1, we will add 1 to both sides. Absolute value, 2x is greater than or equal to 8. So absolute value is isolated, it's greater than. Greater than, go. Got to do or. Take what's inside and rewrite. 2x greater than or equal to 8. The first one does not change. Or 2x, flip the sign, less than or equal to, flipped it. Negative 8, make it negative. Okay. All right, now we just got to solve both, so we got to divide 2, and x is greater than or equal to 4. Or divide 2, x is less than or equal to negative 4. Okay. So here we are, writing down on our number line for our graph. I have a 0, I have negative 4, counted that time, 1, 2, 3, 4, positive 4. Okay, in this case, they're both or equal to, so closed circles. Now, typically our ors shade opposite directions. Let's see if it matches. X greater than 4, greater than goes to the right, so we're shading to the right of positive 4. And at negative 4, it says x is less than. So less than goes to the left. First one is done. We have graphed our compound inequality. All right, another example. Problem says x plus 5, absolute values on top over 3. So to get rid of the division, I have to multiply both sides by 3 times by 3. Rewrite absolute value, x plus 5 greater than 12. So we have a greater than again. Rewrite the inequalities as the compound inequality. So I'm going to take it the way it's written first, x plus 5 greater than 12, or x plus 5 is less than, make it negative, negative 12. Flip the sign, make it negative, okay? Flip the sign, make it negative. So this yielded our compound inequality, okay? Solve both of them. Subtract 5, x is greater than 7, or subtract 5, x is less than negative 17. So negative 17 is pretty big. Again, just put up 0. We have a 7 and a negative 17. I understand that's not to scale. That's okay. I'm not real picky on that. Open circles at both. And should shade opposite directions. At the 7, x is bigger, shades to the right. X is less than negative 17, so at negative 17 we're shading to the left. We have indicated all of our solutions on the graph. So like any number smaller than negative 17 will satisfy the inequality, and any number bigger than 7 will also satisfy the inequality. All right, take a pause here. Give the U-tries a shot. Make sure as you're trying these, you isolate the absolute value, then determine and or. Make sure you rewrite both inequalities, okay? All right, hopefully you had success on number 5 and 6. So, number 5, absolute value is already isolated. I see that absolute value is greater than. It's getting eaten. So greater than means or. Rewrite 4w plus 1 greater than or equal to 11, or take what's inside, 4w plus 1, flip the sign, less than or equal to, make it negative, negative 11. Now we have to solve both of them. Subtract 1 first, 4w greater than or equal to, we have 10. Divide 4, that is a fraction. 10 divided by 4. I like decimals on the number line a little bit better, so it's 2.5. W is greater than or equal to 2.5. All right, I kind of like the decimal on that one as a better option. Minus 1, 4w less than or equal to negative 12. Divide 4, w is less than or equal to negative 3. Or is still in between, so it should shade opposite directions. On the number line, 0, 1, 2.5 is right here, closed circle, because it's or equal to. W is bigger, that shades to the right. And at negative 3, closed circle again, W is less than, shades to the left. So shades opposite directions, okay? Last example here. First step, add the 10. 9 times m minus 8 is equal to 36. We moved the 10 first, add, subtract before we multiply and divide. Now we can divide by 9 to undo the multiplication. Absolute value, m minus 8. Oh, I put an equal sign. That was a mistake. It was less than. Sorry about that. It is still less than. 36 divided by 9 is 4. So, since it's a less than, what do we use? Less than and. So m minus 8 is less than 4, and m minus 8 is greater than negative 4. Flip the sign, make it negative for the second one, okay? Flip the sign, make it negative. Add 8, solve them both. M is less than 12, and add 8, m is greater than negative 4 plus 8 is 4. So we're going in between 4 and 12. So 0 is going all the way over here. 2, 4, 6, 8, 12. Putting 12 here. I went by 2s, okay? Open circle at both. It's not or equal to, so open circles. Typically with an and, we'll shade in between. Let's see if it makes sense. M is bigger to the right. M is less than 12 to the left at 12. So yes, indeed, we are shading in between. 12 and 4 are not included because it is not or equal to, hence the open circles. All right, have a great day. That wraps up chapter 2.